So let's talk about using simulations in probability. Now, simulations can be used in a couple of different ways. If you look at the 7th grade Common Core State Standards, you'll see one way simulations are addressed, and that's by using random samples to draw inferences about populations, and we're going to look at that in just a second. Another way we can use simulations is by determining experimental probabilities of events as opposed to theoretical probabilities, which is what we've been looking at so far. So here's the first example we're going to have of looking at a random sample in order to gain information about a population. So let's suppose we want to know how many times the letter E appears in the Gettysburg Address. Well, the Gettysburg Address really isn't that long, and it probably wouldn't take us that long to count all the E's, but that's not really the point here. We're going to use this as our population. All of these letters are part of our population. And what we're going to do is take a random sample of these letters to try to come up with some sort of guess about how many E's are in the entire Gettysburg Address. So to make this a little bit easier, we're going to take all of the letters and put them together. We're going to take all of the spaces out, and we'll put this in a font that allows us to see exactly the same number of letters in every single line. And to make it even better, I'm going to make the E's stand out. Now, here's what I want you to do. I want you to pick one line randomly. It can be anywhere in all of this text. And I want you to count the number of E's in that one line. In fact, pause the video if you need to so that you can count, and then we're going to do something with those numbers that you get. Okay, so now that you've counted, let's look at some information about that text. So every line of the text contains 55 letters unless you were counting the very last line. The very last line only contained 49 letters. So the first question is, in the line you chose, what fraction of the letters are the letter E? Now think about that and write it down. Pause the video if you need to so that you can write down a number. Okay, so now that you know what fraction of the letters in your line were the letter E, I'm going to give you a little more information. The entire Gettysburg Address contains 1,149 letters. So with that information, how many of the letters in the Gettysburg Address do you predict are the letter E? So stop and think about that, write something down, pause the video if you need to, and then we'll go on. Okay, so I'm going to play this little game. Here's the entire Gettysburg Address. I'm going to pick one line out, and in that one line, I'm going to count the number of E's. So in my line, there are 9 E's. Now this is a line, I just chose at random. There's nothing special about this line. There are 9 E's in my line. Your line may have had more, may have had less E's, may have had the same number. So now I'm going to take my line and I'm going to look at these same questions that I asked you about your line. If every line contains 55 letters, how many of the letters in my line were the letter E? What fraction of the letters? So I had 9 E's out of the 55 letters, so 9/55 of the letters in my line were the letter E. So I would say experimentally 9/55 of the letters in the Gettysburg Address I would expect to be the letter E. Now if the entire Gettysburg Address contains 1,149 letters, and I want to know how many of the letters in the Gettysburg Address I predict are the letter E, I simply need to find 9/55 of 1,149, which is approximately 188. The actual frequency of the letter E in the Gettysburg Address is 165 out of the 1,149 letters. So my 188 is just a little bit higher than the actual number, but it's a number that I got by looking at the population and taking a sample of the population and then coming up with an estimate based on that sample. So let's look at some places where you can actually do some experiments and come up with some samples or come up with some experimental probabilities based on those experiments. This is one website that's great for teachers to know about. It's called Illuminations. It's a website that's created by the National Council of Teachers of Mathematics, and they have an activity that allows you to take a spinner and adjust it to the number of sections you want in the spinner and the percent of the whole circle that's being taken up by the spinner. So we're going to take a look at this and just kind of play with it a little bit so that you can see what it looks like. So let me just bring that up. So here's the spinner. It's got 6 spaces. These are all equally sized at this point. So I could spin the spinner and it would land randomly on a spot, and the table's going to keep track of the number of times it lands on a particular spot. Lime seems to be really popular. That's 3 times in a row. What are the chances of that? You can change the number of sectors. You can even change the percent of the whole that each sector is divided into, so you can come up with some really interesting experiments with this. Now there's obviously that's a nice way that you can take an activity like this and you can create some sort of experiment with it and gather some data. I'd like to mention another way that you can gather data for something similar to a spinner or any experiment, and that is by using a random digit table. So a random digit table is exactly what it sounds like. It's a table that contains random digits from 0 through 9, and you can use this table to simulate experiments. For example, if we wanted to simulate an experiment of spinning a spinner that had 3 equal sections, we might take a part of the random digit table, any part, and make a decision about what numbers represented what sectors. So if I have 3 equal sized sectors, maybe I would decide that a 1, 2, or 3 would represent the blue sector, and a 4, 5, or 6 the teal, and a 7, 8, or 9 the yellow, and the 0 we're just going to throw out. It doesn't represent anything. And then I could go through and I could literally count the number of each of those numbers I have in the table, and then I could come up with some numbers that would represent random spins of the spinner. So I could say, well, if I spun this spinner, this ends up being 117 times. I would expect 44 blue, 40 teal, and 33 yellow. So it's a way that we can come up with some sort of random generation of numbers without actually doing the physical experiment. This is another really interesting website from the University of Colorado Boulder. It's called Plinko Probability, and if you're familiar with the Price is Right game Plinko, you'll know that that involves dropping a ball down a board and looking to see where it lands. So it's a nice little simulation of probability in which the numbers that you come up with do not come up with the same regularity. It's the numbers in the middle are more possible than the numbers on the ends. And this is another really interesting simulation. This one is from the National Library of Virtual Manipulatives, which is also another really wonderful website to explore. And it's a little probability game called Stick or Switch. If you know the game from Let's Make a Deal, where they have the 3 doors and people at the end of the game have to pick a door and they're given the option of switching a door. This is a way to simulate that experiment, and the probabilities come out in kind of a surprising way. So let's look at a real life example of probability that is an experimental probability and that involves having children. If a family has two children, what's the probability that both children are girls? And what we're going to assume is that having a boy and having a girl are equally likely events. Now, we've already talked about ways to organize this information to come up with a theoretical probability, which might be to make a table and look at the outcomes of getting a boy or girl and combining those outcomes to get four possible outcomes that are equally likely. We've also talked about making a tree diagram and including the probabilities in the tree diagram to determine the probability that both children are girls, which in this case would be 1/2 times 1/2 or 1/4. So we can see that in the table, we can see that in the tree, but these are theoretical probabilities. We haven't actually done an experiment to come up with an experimental probability. So apart from actually having children, one way we could come up with an experimental probability is by literally doing some experiment, like perhaps tossing some sort of counters where we might say red represents boy and yellow represents girl. So we're actually going to be doing some of these experiments in class and looking at those experimental probabilities and comparing them to theoretical probabilities. But for now, you can think about how you might design an experiment like this to determine what the probability is that both children we would have would be a girl. And we'll take a look at this in class.